Welcome, everyone, and happy Halloween. We are thrilled you could join us today, whether live or catching us on the replay, for this special holiday webinar. So today, Halloween, which of course means the start of the peak retail season, that's going to be front and center for our conversation today. Now, we're not here to scare you too much, but we do want to unmask some of the potential frights that you all may face as a retailer, or really kind of any industry, whether it's finance, gaming, streaming, travel, communications, and so many more that are impacted by the rapidly approaching holidays and what that means as far as increased in shopping, travel, and everything else that comes with the holiday season. And not to give away too much of our content yet, we're going to get into a lot of details today. But the reality is that this time of year is stressful for many of you on the IT, DevOps, SRE side. We fully recognize that as a tech company. And we also recognize, though, that data is at the heart of much of what you're doing today. It's kind of powering our industry. It's the lifeblood for our applications and services today. And we truly believe that the right database can play a key role in reducing much of the classic stress you face this time of year. So our job, our treat to you on this holiday edition, is to talk through 4 specific ways we believe a database can help make your life easier and help take away some of that stress that's, I'm sure, starting to build as you look ahead to, again, Black Friday, Cyber Monday, and the craziness that comes with the holidays. So with that, let's jump in. The good news is I'm not here alone. I'm excited to be joined by a great speaker who I'll introduce in a second. But quick introduction of myself. My name is Michael Haig, and I'm the head of product marketing at Yugabyte, the modern distributed database for transactional applications. I've been at YugabyteDB coming up on about 2 years now. Before that, I spent time in various parts of the IT stack, networking up to storage, virtualization, and the cloud layer. So I've kind of quickly moved up the stack, excited though on what we're doing nowadays in database and all things data. And joining me to help share specific insights, lessons learned from years of working with some of the largest retailers in the world, I'm thrilled to be joined by Ame Banarse. Welcome, Ame.
Thanks, Michael. Happy Halloween.
Folks, happy Halloween to you too as well. So maybe could you just maybe give a quick introduction of yourself as well and your background for the audience here?
Absolutely, Michael. So folks, I'm Ame Banarse. I lead the global field engineering team here at Yugabyte. So think of us as solutions architects working with our users, the community, even our customers to help you modernize your database architecture. And more importantly, help you design for those peak scalable events and how do you mitigate risks in some of those as well. And those are the best practices we're going to share with you today. And the team basically consists of a really good amount of Oracle, Postgres, DB2 experience as well. So we really enjoy working with some of these toughest of the use cases in the world, especially when it comes to a consumer-facing use case like retail. As per Yugabyte experience here, I've been here with the company for 5 years, and previously I was in financial services with New York Stock Exchange and FINRA. Michael, there's going to be a great conversation today. Let's get to it.
Perfect. Welcome again, Ame. And I know the retail space is near and dear to your heart, so I'm excited to pick your brain on these 4 potential Black Friday frights and how we're going to help reduce the stress of our audience out there. So let's jump right in. And let me start with just a quick 60-second big picture view of kind of how we're seeing the retail industry. As I think about the feedback and market dynamics that we hear from our retail customers, they regularly share this information with us. I kind of group it into these 3 buckets that they're all trying to navigate. First, the industry is in a state of constant and rapid change. While the digital transformation of the retail industry, may have kind of gotten blown up and really started with COVID. With COVID, it happened long before that. And over the past 3-4 years, we've just seen that accelerate. So this constant change, it's the new norm. Shopper preferences, expectations continue to evolve. People are embracing, experimenting with new ways to buy, browse, pay. So lots going on just from kind of the core retail business. Next, we now really are entering this world of just global competition where, again, customer expectations, they're no longer just comparing a grocer's website to a grocer's website or a clothing retail website to a clothing retail website. They're kind of taking all of their experiences across all different websites, whether it's related to retail or not, and saying, hey, this was a really good experience. I expect everyone to offer me that good of experience. So just this global competition and these higher expectations are just driving this demand. And this is coupled with the fact that, online customers are much less sticky to a given retailer than they used to be. There's no hesitation in doing a quick 5-second Google search, finding the product you want to buy from another retailer, kind of another store, and hopping over if they offer an easier, more seamless experience, if they can guarantee that inventory is in stock, et cetera. So this global competition, this increase in expectations, I think is on the rise. And then the final bucket, which is again near and dear to our heart, is across all of this is the overwhelming focus on data and the data first mentality that's required for businesses to be successful today. In order to deliver that seamless, touchless experience that goes from your social ads to an online store, physical store, everything in between, you need that modern data layer, that data kind of DNA that can connect things together, provide those services, and deliver. And so with that thought in mind, let's kind of then segue here to really talk about what we want to today, and that's how do we help improve the lives? How do we kind of make it easier for retailers out there? And it's kind of trying to find some nice light way to start with this. And I was thinking through, I mean, as we think about the digital strategies, I talk to, again, different members of retailers, IT leaders. We talk to people in the DevOps team and SRE teams. They always kind of describe, I kind of get the impression that there's two stages to their life in this retail space. And they're very related. One is they either come to me and they're going through some peak traffic event, so they're really stressed. And so they're like, I've got to keep everything running. They don't have time for anything. Or if that's not happening, they have this frazzled look on their face where they're just waiting for that next period when they're going to be stressed. So they're either stressed or they're preparing for stress, or there's a happy medium, which we're entering into now, which is the November, December timeframe, where they're basically living both worlds. They're stressed and they're getting ready for more stress as the next event comes up. So Amit, I mean, you've seen this yourself and across different retail organizations you've worked with over the past. How do you kind of, do you agree with this? Do you kind of see this in the folks you work with as well?
Absolutely, Michael. We do see this a lot, and this is where like our teams help some of these largest retailers in the world to help battle test and scale test and do chaos monkey testing before we go live for Thanksgiving and Black Friday. And you won't believe, since COVID, since 2020, every month there has been a peak sale event happening. Like there's back to school sale, or there is the way some of the largest retailers in the world are doing. Like there's a Walmart day and an Amazon Prime day and a Target day, which drives a lot of traffic online and in stores as well. So preparing for stress is just not about online retail, it's also brick and mortar. And how do you give that seamless user experience to your end customers? Because end of the day, what customer is coming to you is for that experience, the coupons working, the checkout working. And that's a repeat pattern in general, right? And we're going to touch upon some of these things on how we exactly prepare for these big events in general.
Yeah. And maybe then before we get into that, I mean, maybe just talk through a little bit. I mean, what are those challenges? Like what is kind of coming together to make this such a hard job? And again, for everybody that's out there.
Yeah. I love the fact that you have a word cloud in here, but there should be like 1,000 words, not just few of them. But I'll tell you the biggest ones here, right? As a user, when I'm going online, and let's say I have this set of coupons because I have a loyalty membership with this company, the retailer that I go to frequently, the expectation is that when something is live, let's say an Xbox X is live on sale for 50% off, when I'm adding to the cart and checking out, the expectation is that it just works out of the box. But every so often, either the checkout fails or the coupons don't go through. There's a peak traffic where the web page doesn't refresh at all. And that's what leads to an extremely bad user experience. And at a point, the user myself are going to churn and move on to the next retailer that's giving me the deal on that front, right? So this is where the uptimes, the make sure that the web pages refresh, the crashes. If at all there is a crash, make sure it's to a microservice, it's limited and mitigated by some other mechanisms in general. But ensuring that the checkouts, the uptimes, the payments go through is extremely important in this case. So user experience becomes number one. Number two is, want to make sure that the product that I bought is really in store, in inventory there. So the worst experience I have personally had is I buy something, 2 days later, I get an email saying that, well, it wasn't actually in stock, so we're going to refund your money. That leaves the worst experience possible for a user. And this usually happens because of inaccurate data during a peak scale event. And we do have certain best practices to ensure that this never ever happens when you use backend like YugabyteDB, a distributed SQL database behind the scenes. So yeah, Michael, maybe we can talk through this in today's conversation as well.
Absolutely. And then I think one of the interesting points is we kind of look at this word cloud is, I mean, I think the bottom line is, I mean, all these challenges, they tie back to the data.
Absolutely, they tie back to data. And as I said, right, the data accuracy count, making sure that the latency between the events is minimal, or when a user is applying coupons and the checkout is processing, the payments have to go through correctly. So there are API contracts defined in each one of them. And the most common thing for all of that is a transactional database. It's either your in-house database or a CRM database or a payments gateway. But end of the day, you want to make sure that these things are hardened, battle tested, and scale tested from the transactions perspective.
Yeah. And then I think as we think through then kind of again, we'll get into our 4 topics here next, but I mean, I think the one ask for the audience out there is, I mean, hey, I mean, we believe, I mean, it's time to, again, as you entering this period of stress, think through what's driving you crazy. I mean, and recognize that we know it may be too late to change for this year's Black Friday and stuff. It's coming up rapidly, but there is a better way. So rethink what you're doing with your business critical services and consider how, as we talk through these op topics today, we truly believe a distributed SQL database addresses a lot of the challenges that you're probably pulling your hair out and getting ready to be stressed about for the next 2 months. So with that, then there's, as I said, there's kind of these, let's jump into the heart of our presentation. And there's these 4 specific scenarios that I really want to dive into today. I want to pick out your brain on and kind of get your experiences on how we've helped solve these today. And let me just kind of gloss over these 4 areas. First, how do we make it easier to react to these peak traffic events and the sudden, the massive increase in demand? Number 2, globalization, whether that means supporting a global base of customers or figuring out how to expand that kind of your global expansion plans. How do we make sure that data that you have can reach your customers wherever they are and provide that same experience regardless of where they're coming from? And third, to your point, this one I think may be one of the most important, and it's one of the most aggravating that we'll talk about that can be from a consumer side. But when you don't get that right data, that right accurate inventory, and you're misled, or again, not on purpose, but just given these legacy systems, sometimes it's hard to guarantee that. So let's talk about that. And then fourth and final, and this is one we don't want to scare people too much, but we live in a crazy, chaotic world. How do we make sure we're ready to survive the unexpected, to handle those crazy scenarios that come up and be ready? So that's kind of on track for today. We'll go through each 4 of these, give some great backgrounds on how, kind of where we think technology can help today, and some real world stories on how we're already addressing this for some of our customers today. So with that, then let's get to this first topic and explore how we can get better about architecting for peak demand. And I mean, maybe just for the audience then, just to help kind of level set folks. I mean, when we talk about peak events, again, I did a quick search. You kind of can pull this data. People are familiar with this in the industry. But as I pulled a graph, some Bloomberg research. They pulled some data points from Glossier, a maker of beauty products. So just kind of one of numerous retailers that face this, where you can see their traffic here and their sales data, massive spikes. Black Friday kind of through December, they see these massive increases, again, 10x the sales, 10x the traffic, if not more. And then again, they got another lesser peak here later on where they had a surprise sale. So again, not just Black Friday, but kind of all, like you said, Amazon Prime, all these special days can drive this rapid increase in spikes and in traffic. And so what does that mean? I mean, again, to the DevOps and SRE teams, it means that they have to, again, handle this unpredictable number. They're not sure how massive it'll be. What exactly will that spike reach? Will that social ad that their marketing team try to do take them to that 5x level or the 100x level? You just never know nowadays with the viral nature of things. And then anything that they've added, they change. Again, these new systems, they continually are innovating that haven't gone through a peak event before. There's always that risk. Will it work? Will it? Did we test it properly? Did we find all the corner cases? And then just the human element of it. You depend on people, the teams out there to help support this, but we all want to be home with our family for the holidays. So oftentimes they've got limited teams, limited availability to address things that happen. So all these things that at least I see come together that we need to be aware of on peak events. Anything I'm missing, Ame, or things that you would bring up there?
Actually, that's a great point. So there are few challenges that we usually see in this space, right? So if you go to the next slide, we'll talk about these challenges where it's great that everyone has the same goal in mind. Like any retailer, any employee at the retailer has the same goal that the peak events should be done correctly, our profits are through the roof, and every customer is happy. That means there is a repeat shopping pattern with these customers, right? But there are certain back-end tasks that become extremely time consuming, right? So I mean, starting with traditionally, the database industry has kind of relied on this monolithic legacy systems architecture. They do a fantastic job when it's a single region deployment. All the traffic comes to one single load balancer and handles the traffic for that specific region. But as and when your data grows, you start creating these manual shards. And we often see this happening where there is a separate metadata lookup table, which would know exactly figure out where the shard of the database lies. And then the app would have to do 2 or 3 different hops to get to that shard specifically. And then the worst scenario is when the shard goes out of proportion, you keep sharding it manually, even during the peak event. So it puts a lot of stress on the SRE teams when they're doing these live events. So it's time consuming and it's fragile, which is the biggest issue that we see so far. The second and third kind of go hand in hand. That is, even though you're doing sharding, sometimes you have an opportunity just to vertically scale up the system. So for instance, our folks who run it on public cloud, they're easily able to vertically scale up the instance, let's say onto 96 cores. But beyond that point, it becomes extremely hard to figure out what to do with such a bulky instance. And you have other set of issues coming in, like garbage collection and connection latencies and things like that. And that's where usually customers would think about, let me try to put a cache or an in-memory data grid in front of it to speed up things, which is great. It does help you speed up things and get the end user traffic flow working correctly. But what it leaves you with is the data inconsistency between the cache and a system of record database. And that becomes the most challenging thing to solve for, especially given the fact that you might run into a hot item which is running very low on inventory, and then you end up selling that product to someone which really didn't belong into your warehouse. And that's a challenge that you obviously absolutely should avoid for your own brand awareness and protection in the industry, because retailers, end of the day, it's a margin business today. You have to make sure that 300 odd million Americans who purchase from you, let's say we focus on US at least for this conversation, you want to make sure that you have repeat business coming from them. And you don't want to serve them the wrong copy of data in general. So as we look into this, Michael, it brings up a very good point. What can distributed database help you with, right? So a distributed database, again, we are a class of database, which is YugabyteDB, 100% open source. We built it from scratch with a single point in our mantra that it should be a scalable, resilient database, taking care of HA and resiliency built into the system without doing any patchwork in terms of replication. And more importantly, coming to our users with 2 developer-friendly APIs, a Postgres-compatible API and a Cassandra-compatible API. So it can solve for a breadth of use cases in general. But as you peel that thinking, what you really get from a retail perspective is a database which can automatically shard as and when you are scaling up for the peak demand, and still giving you that linear scale and performance predictness. So that is extremely important, because on a normal day when we work with certain retailers, they do about 250K transactions a second. During a peak event, something like Thanksgiving, they can go 10x, 2.5 million transactions a second easily. So you want to make sure that you help them scale up the database with giving the same amount of P19 and read and write latency at the end user. And we're going to take a look at some of these things today. Cool. Michael, maybe we can talk a little bit more about how do you architect for scale for some of our users here. So folks, again, if you're building a net new app in the retail, right? Here are 4 options. I'll walk you through what exactly you'd be thinking about. Number 1, let's say you have to scale. The best possible option for you is, let's say if you're running on public cloud or on-prem providers like VMware or OpenStack, simple enough, you can say, scale up the virtual machines, give it more cores, and get done with the problem as and when needed. It's okay. There are certain limitations based on the hypervisors on how many cores you can actually get. Assuming that's still doable, it is disruptive. This is not going to be a seamless, no downtime operation for you. That means you will have to creatively figure out what to do with the live traffic until the instance is actually scaled up and getting back the traffic from the users. And more importantly, this is where the challenge occurs. You're able to scale up during a peak event, but it's extremely hard to scale down. So what we typically see as a pattern is that customers would take a full backup of the scaled instance with limited data, start a new instance completely with smaller set of cores, and reload that data. That means it's an extremely manual task, and it has some margin for data loss in general, because you have to handle the live traffic and change data capture on another messaging queue in some sets. And that's where the option 2 comes in. If you don't want to go through all of that, typically what you do is you start creating smaller shards of this database rather than touching a single database instance, which is again a great idea, and it does work perfectly for most of the users here. The challenge becomes that you now have to have an in-house expertise whose only job will be to map out this metadata for where the shard belongs. And the challenge, as I mentioned before, the challenge starts for the application team on figuring out the shards. And if at all a shard is getting beyond a certain data size, then how do you break that shard real time into different shards? And it just becomes cumbersome to manage, especially at the peak scale when you're trying to sell millions of users at the same time. That's where we get to option number 3. That is, you let go sharding, you let go scale up, you just simply add a cache in-memory data grid in front of your database. Problem solved for that instance. It's perfect. Seamless user experience to your end users. The latencies are amazing. The throughput is amazing. The challenge is, how exactly are you going to keep the cache and the system of record in sync? And that's where it opens up a huge window of data incorrectness and inaccuracy guarantees to your end users now. And that's what you need to solve for. So it's a patchwork on a different level, but you still end up with some other problem. So the last one that we totally recommend is just go out onto a distributed architecture. That is, pick up a database backend, which can exactly automatically shard and scale for your peak demand, giving you the same performance predictability even during the peak scale. And you can scale back seamlessly as and when required. And this is where we have invested for last 7 years, the entire R&D and the field expertise to ensure that we're able to handle such design patterns with YugabyteDB. And we're going to take a look at some of the real examples here in a bit. So Michael, hopefully this was good for you to hear on how exactly what kind of problems you see in the industry.
Yeah, I love that discussion. I know, again, scale, when we talk about peak events, scale is top of mind. And again, these are the options people face, and some are better than others, and some are very painful. And I'm sure, again, the audience out there is thinking, oh, I wish I didn't have to do this for the next coming months. So I love that, and agree that the goal of what we're doing with distributed databases is how do we, again, just make that scaling just natively part of it, so it's automatically in the architecture, spread the data out, understand how to handle it, and relieve folks from all these burdens. This is great. I'm going to jump into the next slide then. I mean, I know we've got to, again, let's pull in some of our real customers out. Let's kind of talk through how we're actually seeing people solve this today. So maybe talk through what we're doing here with this major retailer.
Absolutely, Michael. So folks here who are attending live, and then we'll catch up the recording later. We work with one of the largest retailers on the planet. That means this retailer has a massive .com presence and about 5,000 odd brick and mortar stores that all of us actually shop day to day as well. And globally, they're a global platform in general. So what we do for them is we are a system of record for their global product catalog. That means if you buy any product from them, Yugabyte actually stores the metadata, the content, the entire information about that global unique identifier for that product. And then based on that, we also power some of the downstream applications which would need this data every now and then. So when you look at some of the key requirements for such a use case, right? I mean, it has to be high throughput, low latency style system, because as you can imagine, if you're selling selling your products to a massive population in store as well as online, it's going to come with a huge amount of traffic in general. The second important thing is that the catalog style use cases have a pattern of doing a very bulk write, maybe for 4 hours a day, 4 hours in a day, usually around midnight time. And then rest of the day is extremely high throughput in terms of reads. That is, people are just actively shopping. There are very few updates that go on to your catalog. Usually, if it's a product recall or product is out of stock, then those are a classic examples of writes happening. Or most of them are reads in general that people are shopping, buying products, buying a group of products and things like that. So as you can imagine, strong consistency and data accuracy becomes one of the most important criteria for selecting a database. And that's what Yugabyte provided to this team out of the box, and ensuring the fact that you can do asset compliant transactions. So you can roll back gracefully without any issues. And more importantly, you are able to look up the data without actually giving a primary key. So you can do slice and dice based on secondary indexes as well, becomes important. Now, the other side of the story is always cloud native thinking. How do you apply your SRE principles, treating infrastructure as a code, and automating all the pipelines so that scale up, scale down, replacing a node, routinely upgrading the software versions becomes extremely easy. And that's what Yugabyte provides out of the box, because fortunately, we were born in the cloud native era where these things are just a norm, and we didn't have to do anything to build this. This is handled automatically by Yugabyte. And double that with the fact that when we develop database from scratch, we actually ensure it's a platform agnostic database. That is, we have this team who runs it on virtual machines for us, given in their private and public cloud both. But also we have customers who run Yugabyte on Kubernetes or bare metals. And that gives you the deployment flexibility that this global retailer truly valued, because now they are able to think of Yugabyte architecture in virtual machines and closer to where their customers reside on the edge deployments in their stores as well. In the past, again, we've been working with them for about 4 years now, but in the past, they had another set of NoSQL database called Apache Cassandra, which obviously wouldn't give that strongly consistent copy of data during peak events. And more importantly, in a multi-region kind of a situation, the transactions latency and throughput became extremely worse and worse as and when they scaled up during the peak events. And that was a primary reason to replace Cassandra in the first place in here. Now, if you look at the next slide, this basically talks about what results have we seen for the last 3 Thanksgiving with them. This is the 4th one that we're going to be upcoming on. So as you can imagine, we routinely scale up the clusters. We help them battle test, do chaos monkey test. We actually kill a node, a AZ, or an entire region just to ensure that the RTO for the end user is absolutely 0. And that's built into the box in Yugabyte. In a multi-region topology, like the way we have deployed for this use case, you can actually lose an entire data center without any issues, but you can also scale up and scale down routinely with absolutely no performance degradation to the end customer. So some of the numbers that you folks can see here, like typically we do about 250K business transactions a second, which kind of translates into about 1.25 million IOPS from database perspective. And then reads and write latencies on P99, reads are about 3 to 5 milliseconds. The writes do have to pay the penalty of cross data center traffic or cross region traffic from Azure perspective. And that's what guarantees you a full HA and resilience in case you lose one entire region in any disaster. And we'll talk about the disasters in a bit in our next trick or treat as well. But again, folks, imagine this. If you ever shop anywhere in this retailer, that means you're using Yugabyte day-to-day for at least last 3 years in general.
Awesome. I think that's great. And again, for this treat number 1, again, I think the key message there is again, think about architecting for that scale, having a system that can go up, down, that doesn't hit a wall, doesn't lock you in. And I think that's powerful with some of the modern technologies, allowing retailers just to have that flexibility and that freedom. And then you hit on some other things, both kind of the deployment topology, the resiliency. We'll cover those in a little bit more details as well, because I think those are critical as well. So on that note, then let's jump to this our kind of second point here, our second treat here, which is this idea of designing for those global shoppers. So how do we not just support that global audience, but also make sure we're giving that consistent user experience to everyone out there. And just a kind of quick data points on why this is important. I mean, I know from my personal shopping experience, I've started to buy from international companies a little bit more than I would have in the past. There's a candy store specifically in Switzerland that I stalk because I'm just waiting for them to expand out to global shipments because they're my favorite gummy bears. But that's a personal point that we'll save for another day. But this idea that shopping's increasing internationally is key. I mean, some quick data points. In fact, 54% last year of US digital shoppers bought some from foreign sites. And a couple of years ago, we saw kind of that total amount of commerce cross that $1 trillion mark, which means, again, there's just this massive appetite, this expectation now that we're not just shopping from locally, which is still important, but that we have those choices to shop and buy from kind of anywhere around the world. But of course, with that, Ame, comes its fair set of challenges. I mean, this hasn't been easy in the past with traditional systems. You alluded to that a little bit before, but maybe talk us through those challenges retailers do face in kind of doing this global expansion.
Absolutely. So this goes back to a point where most of the retailers back in the day used packaged applications. That is, application packed with the database, kind of an appliance model, put it in your data center, and kind of let entire global traffic come to that one single data center by paying the latency hit. Now, the issue in this case is that one single database, whether it's a single node or a cluster of nodes in one single data center, it's limited by the bandwidth given to you. That is a single writer. That means, like as you said, imagine in your Switzerland example, Michael, that you had a data center for that company who's selling you these chocolates online in Switzerland. You're easily paying up to 150 milliseconds back and forth from US to going to Switzerland. And that high latency for a single writer also becomes a choke point as and when you're giving that good experience to the end user, right? So kudos to you that you keep buying these chocolates from Switzerland. And I'm hoping your experience hasn't gotten better over and over. But it also comes with other set of issues, right? There are certain complex deployment configuration options that people go through. They will kind of create 3 or 4 different regional clusters to ensure that they are able to gather or like serve the regional population. And then they would do once or twice a day kind of a bad job to keep all the data in sync, which becomes extremely hard and cumbersome and has, again, the ability to serve wrong data for wrong users in general. So again, an issue that we routinely see. And the third and the most important thing is, as and when the user privacy laws are being enacted by every single retailer and the geographies itself, it becomes hard for a single writer monolithic style database to actually go and satisfy the end user requirements. That is, the compliance team from these governments are going to be ensuring that your business cannot operate in their jurisdiction if you don't keep that user's data in that data center in that jurisdiction. So what they typically do is they will try to create a regional cluster in every single case and go back to model number 2, which kind of fails in the first place. So these are the issues that we typically see. And that's where Yugabyte comes in to essentially solve for this using a creative terminology that we came with. It's geopartitioning, or row-level geopartitioning genre. But starting with how can a distributed SQL database help, right? So number one, we help you essentially deploy a database which is single cluster across these multiple geographies. And with that, we would still help you ensure that your end user data for a specific geography is only kept in a set of nodes which belong to that geography, even though the Yugabyte cluster is spanning across the globe. That becomes a very powerful feature to help our customers meet the end user data residency requirements. Number 2 is we give you flexibility. If you don't want the global single cluster, we give you flexibility to deploy multiple Yugabyte clusters in different geographies and handle the data replication ourselves. And this includes deploying it on bare metals or Kubernetes or virtual machines. We are completely fine with either of the options in general. So on the next slide, let's take a look at the top 4 options that we would see. But before that, let's look at what does a globally spanning database really mean? Because a decade ago, this was just a theoretical concept that a database can actually span multiple regions. But today, it's a reality. So We just pulled up this topology from a real use case that one of the customers does here. When you look at this, it's a single cluster of Yugabyte that is spanning Americas, Europe regions, and Asia Pacific. And the numbers there denote the latency between each of those data centers as and when the traffic occurs. But the beautiful part about this system or this topology is that you can scale up on demand. Again, you're highly available even if one entire continental data center goes down. So we assure you that in a replication factor 3 scenario, which is like this, even if you lose one entire region, your RPO will be 0 with Yugabyte. So that's something that, since your replication factor becomes 3, we keep the copy of data in every single geography in this case, you're rest assured that if at all a disaster strikes, you're covered. And also the RTO, the recoverability and of the traffic, and ensuring that from the failed region, it goes back to the other 2 live region. It's instantaneous. It's usually less than 10 seconds, as and when we have measured. But it also depends on your global load balancer and networking load balancer configurations in general. But the beautiful part about this, again, is that I can assure the end user that your data in the US residency remains in US, even though Yugabyte nodes are spanning in Europe and America and the Asia region as well. And when you come to the next slide, these are the patterns we typically go with. So the one that we showed you right now is the pattern number 1, which is a stretch cluster. That means it was an active pattern where we can afford to lose a zone or a region or an entire data center, and giving you that flexibility with RPO and RTO. The other pattern that you can do is have 2 separate independent clusters. Let's say an independent cluster in London, the other cluster in New York. You can pick and choose the database objects that you want to replicate in either an active or active passive DR style solution. And this will give you very high throughput and very low read and write latency in each of the data center, but we eventually replicate the data on either of the sides. So pretty powerful feature if you're partitioning your users with east and west traffic patterns in general. The other option is read replicas. That is, in a global deployment, if you want your traffic to be locally served without putting the pressure on the main cluster, then you can quickly create a read replica for such a use case. Usually we see this pattern for a downstream application which wants data from a system of record, but without putting a lot more pressure on the system of record. So just a low latency, very high throughput system in general. And the fourth one, which kind of spans across these 3, is the geo-partitioning option. That is, we can now say that given a data for that user, let's say user ID and the geography where they're located is a simple column, we can ensure that the data is pinned to that geography based on the value that they provide in that column, whether it's Asia, US, or Europe. And that's completely handled by Yugabyte. And as and when your application interacts with the database, we will serve you the right copy of data automatically. So that's a powerful feature. Again, Michael, you don't have to go through any loops and hoop of routing the traffic elsewhere, completely transparent to the end user from that perspective.
Yeah, man, I know that some of the retailers we've worked in the past, having this flexibility of synchronous and or asynchronous and the read replicas, kind of bringing all that together, just gives us great flexibility where based on the application, like some services, you may want the kind of, you need the data accuracy, consistency, maybe others asynchronous is okay, and you want more of the performance. So those trade-offs I know are just powerful. So it's great to see kind of all this summarized together. I love this slide of the quick snapshot. So then let me then kind of getting back to real world, talk us through kind of what you're seeing in the real world with this one.
Yeah, absolutely, Michael. This is again a fantastic use case that a lot of us would actually touch. So we work with this company called Admiral, and I believe we've been working with them since 2019 days. And Admiral is one of industry's leading visitor relationship management platform. So think of it as when you go to some of these giant publishers in the world, like CNBC, Golf Digest, CBS Interactive, or even Board Panda, they actually help you streamline the audience engagements on these platforms. So they kind of come in as a spin on CRM. That's why it's called VRM, Visitor Relationship Management. And they would help you simplify a user interaction, whether it's through registration, bookmarks, reading pages, and still ensure privacy and compliance with the GDPR and CCPA laws as well. And this is again a good use case from the other perspective, that when we met with this team, they were using a specialized database called ClickHouse to handle some of these things, but it lacked this horizontal scalability approach. And with a growing set of customers that Admiral kept adding to, it was extremely hard to scale up and still meet the end user compliance requirements. So what we did was we helped Admiral completely migrate onto Yugabyte's fully managed service. So this is a fully managed DBaaS service out of the box. A user can go to cloud.yugabyte.com and start using Yugabyte right away. So the entire SRE operations, that is data automation, provisioning, is managed by SRE team at Yugabyte. And from the end user, you're just putting your app developer and architect hat on it and start using the database right away. And this is how we have worked with Admiral team to essentially give them the SLA and ensuring that they are able to do a geo-distributed topology with multi-region as well as read replicas. And routinely, we would help them scale up the clusters to meet the end demand as and when there is peak traffic in some of these publishers that come in. And the second thing is we would help them essentially do rolling upgrades without any downtime and getting to scale events without any infrastructure issues whatsoever. So from their perspective, it's much lower TCO and much better proof of value that they get from the entire database platform. So if you folks are excited about this one, let's ensure that we send them the blog again later, Michael, as part of it, because there's a fantastic blog on how Admiral helps Yugabyte with the entire topology.
Absolutely. Yeah. I think that's a great story. And again, a great testament to that flexibility of deployments and taking advantage of all that. So with that thought, I'm conscious of time here, and we want to give two more treats out on this Halloween day. So jumping to number 3, and to me, this one again is maybe kind of one of those critical ones, but how do we help find a way to ensure that accurate inventory results? And again, you alluded to this in your opening. I mean, to me, one of the most frustrating things as a consumer is when you go through that process of finding something to buy, deciding where to buy it, completing the checkout process. For me, getting off the couch and getting my credit card, if it doesn't auto-populate, which drives me crazy, and then suddenly you go through that process, you hit checkout, and then you get one of these messages. It's like, oh, sorry, it's out of stock, or even worse. You order it, you go to sleep, you think all is good, you think your product's going to come the next day or two, and then you get an email a day or two later saying, sorry, there's been a delay, we won't be able to provide it to you. I know from a consumer it's frustrating, and I know from a retailers, again, they're not trying to do this. I think it's frustrating to them as well. They want to capture that demand when they have it, and they want to provide that right experience. But a lot of times, to me, this comes back to the fact that it's an indication that they have systems, they have data that's just not connected. It's just not consistent across what's available, what's been ordered just within that time period, and leads to frustration. So I love your comment up front, because it's a pet peeve of mine as well as I'm sure a lot of folks out there. So then talking about the challenges, then why is this so hard today?
Yeah, I mean, this is actually a good, and I think, Michael, those are your own screenshots. That means you have ordered products that never came to you. That's good to know. So, Michael, typically this happens because the backend databases, about a decade ago, there was a huge onset of NoSQL database in the industry. That is, you cater to speeds and feeds, but you use an eventually consistent architecture just to achieve that throughput and read-write latency on the end user. But the eventual consistent architecture has this huge drawback. That is, as and when you're selling a hot product that you're trying to buy and that goes out of stock, that means you ended up selling a product to an end user which did not exist in your warehouse. That means you have two options now as a retailer. You can buy that product from some other store yourselves and sell it at a loss to your end user, or just apologize saying that, hey, we couldn't fulfill your order, right? And seems like they did the latter option with you by sending you an apology email. But that's not a good user experience. I can bet you, just like yourselves, most of the other repeat buyers are not going to go to that store and buy that. That means the retailer now has lost an end user from that perspective, right? So eventual consistent architecture do give you that kind of a scenario very often. The other one is during a peak checkout or a peak scale event, you end up throttling and you end up scaling the database in a wrong time, leading to a failure. And this usually happens when a replication link between the databases fail. And a failure leads to downtime for the end user. That means it's kind of in a limbo state where your order went through or not. And that again is a bad user experience in general. And the third one is usually we see this in packaged application and less with the cloud native greenfield applications, but the complex logic in the app kind of hinders that innovative thing. That is, your UX can be easy enough for the end user, but if you add it in a very clunky kind of a packaged application scenario, then it's going to be very hard to like demolish that monolith and convert it into microservices. And that puts a lot more pressure on the SRE teams to keep it live, even though it's not scalable beyond a point. So one example comes to my mind from this would be, again, the next slide is fine, Michael. So this is where Yugabyte can help. That is, we essentially build the database from grounds up to give you that asset compliant transactional layer with strong data consistency. And as we explained above, in the previous sections, we have built-in HA resilience built into it. And if at all your downstream systems need access to Yugabyte data, as and when the data is getting written into Yugabyte, you can do a strongly consistent change data capture stream and capture that in any messaging queue as you need. So example that comes to my mind is a company that we work with, our users. It's called Narvar. And yeah, and Narvar is something that, again, as I mentioned, a lot of you folks, if you shop online, in at least in the continental US, you have touched Yugabyte through Narvar all the time. So Narvar gives you that cloud native app experience when you're doing checkout or buying products in some of these topmost brands in the world, like Levi's, Nike, Uniqlo, Walmart, kind of a thing. And they put this white labeled experience. So that means when you shop a product, you buy, and until the time that product is delivered to your own doorstep, the entire user interaction, whether it's emails, push notifications, tracking your packages, figuring out how many reward points you collected, all of that is handled by Narvar end to end. And this also means that it's a very important user experience engine that most of the retailers consume. So when we worked with Narvar, they were using Amazon DynamoDB, and they were unable to go and satisfy some of their own end customers who wanted to not run their systems in Amazon. Like they had a choice of running on Google Cloud or Azure. So that was one important thing, that is we helped them satisfy these multi-cloud requirements. And also we've been working with Narvar team for last 4 Thanksgiving. So we have always helped them scale up during the peak seasons and also help meet the end user compliance, as we talked about in trick or treat number 2. So end to end, these are the few business impact metrics that I can quickly read out. That is, routinely we do more than 10,000 reads a second. During Thanksgiving, Black Fridays, it does go much beyond that. Let's say on an average annually, this is what it comes down to. Since it's a multi-zone architecture, single region in Amazon, we routinely do reads of less than 3 milliseconds and writes of less than 10 milliseconds. And these are actual business transactions that occur, leveraging some of our core concepts like secondary indexes and JSON-B data type as well. So the schema flexibility becomes very important for Narvar to achieve that level of throughput and meet the end user read and write latency SLAs as well. Cool. So Michael, in the interest of time, let's quickly do the last trick or treat here.
Awesome, Amma. Yeah, let's jump into it. So fourth and final point here, and that's how do we start to mitigate those risks? And again, not to try and scare people, not to be doom and gloom, but the reality is it feels like at least that we're seeing more and more natural disasters. We're just seeing more and more scenarios where people are having to react to have downtime, whether it's cloud outage due to technical reasons, whether it's floods, fires, et cetera, the latest natural disaster. We live in a world where we just need to expect the unexpected and be ready for it. So as we think through preparing for kind of all these things that may happen that could disrupt our business, give those user experiences kind of the wrong impressions about our readiness. I mean, why is this hard today? And then let's kind of close with looking at kind of how YugabyteDB helps solve that.
Yeah. I mean, some of the challenges here is that, again, Yeah, remember one thing, right? During the peak events, if you have a downtime, that means pretty much lost that end user coming back to your website again, right? And this has happened to one of the largest brick and mortar companies 2 years ago. That is during Thanksgiving sale, they they ended up having a huge downtime because of a bug in a CRM system, and eventually last year they got bought by another retailer in general. But this becomes problematic, right? It tarnishes your brand, your reputation, what all you've built for yourselves over decades as well, right? And there's a stiff competition from the online retailers anyways. So the most important thing here is that ensure that the resilience is built into the data architecture. Do not try to solve it by doing a patchwork, by replicating the data yourselves using queues or messaging queues or on any other systems yourselves. Ensure that the database architecture is providing you that. Number two, as you said, poor RPO is going to hurt customer experience, but there are ways to mitigate this. And with that, you can also help cater to your own SRE team, your DBRE team in a retail company, by ensuring that they get infrastructure as a code kind of principles, and the rolling upgrades or scaling up, scaling down becomes easy tasks as opposed to manually racking and stacking the machines. So we're going to take a look at some of these again, but let's take a look at how can a distributed SQL database help, right? First things first, as with us and other distributed SQL database companies, we have built-in resilience. That means it's not a patchwork. The replication of data, rebalancing of data, sharding is completely handled at the database storage layer inside Yugabyte, which essentially means that for an end user perspective, you're getting a very low RPO. So as we explained, RPO of 0 in that topology in multi-region cluster, a multi-region stretch cluster, or in the async situation, it's still very low RPO based on how you configure your load balancers. And the RTO same as we had discussed previously, but it's built into the system. That's not a patchwork, that's not coming on top. And the third thing is, everything that we do in Yugabyte is always exposed with APIs. So that means you can just call on an API through Terraform or Ansible automation or any other IAC code of your choice, and quickly do routine maintenance operations like provisioning a cluster, scale up, scale down, rolling upgrades, config management. These are just simple tasks that you already have a set of Terraform runbooks already available to do that. So now let's put this in perspective. Let's see what happened in reality 2 years ago, 2.5 years actually, right? So we, again, as we had mentioned, we work with a bunch of global retailers on the planet. So this is an example of another use case from a global retailer. That is a simple deployment. This use case was very similar. That is, they would be a system of record for catalog and help their end users buy bundled products, a bundled set of products from this use case itself. So given the fact that it was a multi-region deployment and they chose Yugabyte for strong consistency, that means data coming from traffic coming from central US or east or west will always see one single copy of data. There is no room for eventually consistent or phantom reads or dirty reads kind of a system here. And more importantly, we were the system of record to help them sell about 100 million products with billions of product mappings. And a mapping is typically, let's say, you buy a Nike t-shirt, black color, 4 different sizes, 10 different colors. Those are all individual product mappings for a Nike t-shirt. So that's what we would hold the data. But what happened was in Jan 2021, there was a huge power outage in the state of Texas. And we ended up losing the entire Texas data center for this customer. That means 9 nodes out of the 27 nodes in Yugabyte turned off completely for the next 4.5 days. So the way Yugabyte works is that we detect the failure. The other nodes which are alive would detect the failure. And from the user traffic perspective, there is no data loss. That is, RPO is 0. Your data is very well preserved and kept in US East and US West. And there is an automated, so the end application, the application drivers in Yugabyte will detect this failure and reroute this traffic to US East and US West. So the observed RTO for us in this case was less than 10 seconds. It's also based on the fact that the traffic goes through their Azure load balancers and comes to the US East and US West automatically routed. But what was perfect in this situation was that after 4.5 days, when the Texas power came back up and the nodes were restored, there's an automated recovery procedure in Yugabyte. That is, there is no manual intervention required to copy the data from US East and US West into the US Central cluster. As and when the nodes come up, they would go and do a bootstrap process to take the updates from the US East and US West for the data and get back the traffic live for the entire country. So this was a scenario, Michael, where we got battle tested in real life because Texas had a power outage. And this just routinely happens. So what we do is, as and when we prepare the retailers going online for Thanksgiving to Black Fridays to Boxing Days, we would routinely do this resiliency events with them. So we got this chaos monkey testing. We would kill a node or two or entire region at times and just help them plan for the worst failures and help them mitigate this by creating runbooks custom to their environment. So hopefully the story resonated with you, Michael.
Yeah, I mean, I love this story. I grew up in Texas, and I wasn't there during this storm, but it was crazy. But what I love about this story is it just highlights the fact that as you think through the different database options out there, there's again a lot of classic traditional databases which have powered services for years and years, but there's a new generation of solutions just have a different storage architecture. We've just taken a different approach to how data is handled at the storage layer, how it's distributed, and that's just part of the DNA. It's just what we do. So things like this, being able to again just move over to the other clusters, rebalance it back, is just part of what we do. It's not part of that add-on that kind of bolted on, because we've again taken the learnings of those classic transactional databases and then applied all these cloud native principles to really come up with something new and different. So for everybody out there, we hope these kind of stories have helped kind of shine light on what we're doing. Conscious of time here, so maybe just kind of some quick closing thoughts here, Ame, to leave the audience with. And again, as you head into this peak season, everyone, I mean, think through, how are you handling peak demands? How are you supporting global shoppers? Do you feel you have accurate inventory where you're not going to send me an email saying you can't deliver my product? And then are you ready for these unexpected events? I think these are 4 scenarios that distributed SQL is just uniquely built to handle, and built from the ground up, really kind of taking a new approach in what you may be using with traditional databases today. So those are my thoughts on Ahmed. Let me kind of flip to, I know you had a couple here you wanted to hit on.
Absolutely. So again, all the retailers and any other industry domain participants out here, right? What we do at Yugabyte is we will help you roll out your own database as a service internally. That means either you have an option to come to Yugabyte Managed DBaaS, cloud.yugabyte.com, or the same software can run inside your data centers or your virtual private clouds. But the main goal is that from your user's perspective, they get a fully automated DBaaS. Your cluster provisioning, all the data automation is managed by your SRE team or DevOps team. And it has extremely good enterprise integration when it comes to monitoring, observability, metrics, all those kind of things. And lastly, as I had mentioned, we are a platform agnostic database. So you can deploy it on any orchestration engines that you would want. Typically, we see a lot of our users using virtual machines. There are some with bare metal, some with Kubernetes as well. So pick your poison. You can run it as and when you want, but you get the same exact experience from the DBaaS itself. And then on the next slide, would love to close out with like what you can do to architect for zero downtime, because as a retailer, you want to make sure that everything you do has zero downtime impact to your end customer. So we touched upon the left-hand side, multi-region stretch. We walked you through certain stories with US East, West, Central kind of deployments. The other one, again, is just to notify here that you can do a multi-region async architecture between 2 random cities in the US that we picked, St. Louis and Kansas. But you can essentially do this across the globe without any issues. And in a cloud native scenario, you should just assume the disasters are gonna occur. So ability to go and develop systems and ensuring that you are protecting against these failures becomes the most important thing, with the goal that user impact should be minimal or about zero at the end, is what our teams would help you do that as well. And lastly, just wanted to leave you with one thing, that is YugabyteDB is a distributed SQL database. So Michael, if you go to the last slide, yeah, it's a distributed transactional database, right? So you get 2 APIs, SQL and NoSQL with us. And as we discussed so far in our webinar, scale and resilience is completely handled for you. That's never going to be a patchwork. And we would love to be your partners as and when you're modernizing your next generation of services itself. So, Michael, with that, back to you.
Awesome. Thanks so much, Ame. Really appreciate you coming in today, sharing all these insights. And for everyone out there that tuned in, catching us live or the replay, thanks for joining us. If you have any additional questions, feel free. You could reach us anytime on our Slack channel, or if you want to jump right in to experience YugabyteDB, go to cloud.yugabyte.com. You could sign up for a free cluster and get started today. We hope this was informative. We hope you're getting ready for a great shopping season. Enjoy the rest of the year, and we hope to hear from each of you in the future. Thank you.
Thank you.